Okay, once again, we're working with radicals and expressions under the radicals that need to be demonstrated that are greater than or equal to 0. So x squared minus 7x plus 6 needs to be demonstrated that what values of x are going to create greater than or equal to 0. I'm going to factor this and turn this into two linears, and then I'm going to use just the equal sign here. So I'm going to find out just the equal to 0 first. So x squared factors into x times x. 6 has many choices. You have a 1 times 6, you have a 2 times 3, you have a 3 times 2, and a 6 times 1. I'm going to use the 1 times 6. 1 times 6, that'll give me a 1x and a 6x. According to this right here, the signs have to be the same, and we need a negative 7x. So if I use negative here, that does give me negative 7x. So negative here, and we have two linears. Now if I solve for both linears, x minus 1 equals 0, set them both equal to 0. X minus 6 set equal to 0. And if I solve this one on the left, I'll get x equals 1. If I solve this one on the right, I'll get x equals 6. So on the number line, this tells me I can use 1 and 6 as solutions or as input. So I'll darken those. The thing is, I need to know about these three areas. Will these three areas, are any of those positive? So what I want to do is graph this equation and to see which parts of it will be positive or negative. Because if there's a part of it that will be positive, I know that's the greater than 0 that I need. So we're going to use decimals again. And we're going to put our equation in. F of x is going to equal x squared and minus 7x and then plus 6. Okay, there's our graph right there. And I can see behind 1, all of this part right here is positive. See, the graph is up here. When it's in the upper portion, this is positive. If it's down here in the lower portion right here, that's negative. So I know everything back here on the graph is, everything behind 1 is going to be positive. Everything between 1 and 6 is going to be negative. But everything after 6 is going to be positive according to this graph right here. So let's put that in. According to the graph, this is positive, this is negative, and this is positive. I want the parts that are greater than 0, so I'm going to shade this part right here. This is positive, and I'll shade this. So this represents my domain. So I'm going to say my domain will be this portion right here, which is the negative infinity to 1, and we'll include 1. Also, we get to use this part right here as our domain. This will be 6. We include 6 all the way to positive infinity. So our domain will be any number here or here would allow this graph to function. Okay, let's try that again. Okay, so we're going to take the radicand out. X squared plus 5x plus 6. We're going to set that equal to 0. Well, originally it's greater than or equal to 0. But then we're going to look at it as equal to 0. And we'll factor into two binomials. X squared becomes x times x. We have lots of choices for 6. Again, 1 times 6, there's 2 times 3, there's 3 times 2, and there's also 6 times 1. I'm going to choose my 2 times 3 this time. 2 times 3, which gives me 2x and 3x. And we see that the signs have to be the same, and we have to get a 5x, a positive 5x. So the same signs I'm going to use is plus and plus, and they do give us a positive 5x. So I'm going to use the first plus here, second plus there. So we get two answers. So x plus 2, we'll set that equal to 0. And x plus 3, we'll set that up equal to 0. And we'll solve for x. So minus 2, we'll get x equals -2. Over here, minus 3, and we get x equals -3. So let's put these on the number line. We have a -3 there and a -2 there. And since this is equal, we get to use those 2 points. The question is, these areas, these 3 areas, which ones are usable? So let's go back to Desmos and ask Desmos to show us what's positive areas and what's negative areas. So I want this to be a plus 5x, and I want the last one to be a plus 6. Okay, there we go. All right, and I can see that everything behind this -3 right here is positive. Everything between -3 and -2, all this part, that's negative because it's underneath. And everything to the right of -2 is up here positive. So I see the positive, negative, and positive parts. So let's go ahead and just kind of label those parts. This part is positive, this part is negative, this part is positive. So we want the positive parts, which is this part right here and that part right there. So I'll say my domain is this one right here, which is -infinity to -3, and we'll include -3. Union with this second part over here, which is from -2 to positive infinity, in parentheses here, and that'll be my domain.